Hey everyone, in this AP Chem series video, we're going to take a look at subatomic particles and isotopes. So let's start off with a quick overview of atomic structure by analyzing a sample of diamond. Diamond is unique because it's one of the forms that pure elemental carbon can take on. That means the only particle that makes up a sample of diamond is carbon atoms, like the one shown here on the bottom right. Now, just like all atoms, there's three subatomic particles that make up these carbon atoms. Those are protons and neutrons, which we find in the nucleus, and electrons, which surround the nucleus in energy levels. The protons and neutrons are the heavy parts of the atom, and they have equal masses at 1 AMU, or atomic mass unit each, whereas the electrons are so insanely light and small that we say they have approximately no mass whatsoever. Now there's two main ways that we describe atoms like this carbon atom shown. One of them is the atomic mass. The atomic mass is just that. It's the mass of an atom, which you find by adding up the only two subatomic particles that have mass, the protons plus the neutrons. The other way we define an atom is by the atomic number. This is simply how many protons it has, and it's extra important because the atomic number defines the type of element that an atom will be. That means right now the only thing causing this atom to be an atom of carbon is the fact that it has 6 protons. If we could somehow add an extra proton to that nucleus, making it go from 6 to 7, now that there's 7 protons, it's a completely different element. In fact, it's no longer carbon, it's now nitrogen. If we did the same thing, but instead added an extra neutron, that wouldn't affect the type of element it would be. Even though there's a different number of neutrons, it's still nitrogen. It's technically just a heavier nitrogen. We could do the same thing and add more electrons. These extra 2 would go into that outer shell. It would still be nitrogen. It's just now a negatively charged nitrogen because we've given it extra negative particles. This important list makes up some of the key ideas for this video, so it's a good idea to pause and take a moment to write them all down. Next, let's talk about something called isotopic notation. This is a symbol used to describe the subatomic particles inside a given atom. So instead of drawing out this entire atom and all the protons, neutrons, and electrons that it has, we can instead just use this quick notation style right here. The X is the atomic symbol, the Z on the bottom left is the atomic number, and the A on the top left is the atomic mass. So if we were to apply this notation style to the carbon atom shown, I'd start off with a capital C because that's the element symbol for carbon. I'd put a 6 on the bottom left because this atom has 6 protons, and I'd put 12 on the top left because there's also 6 neutrons, and 6 plus 6 gives me a mass of 12. We use this notation style a lot in chemistry, and it's another key idea for the video. Make sure you pause and write it down. So with that, we're finally in a good place to talk about isotopes. Let's take a look at these 3 different carbon atoms I've selected here. The first one is carbon with a mass of 12. The next one has an extra neutron, giving it a mass of 13. And the last one has a mass of 14. I've chosen these 3 atoms very specifically because they are 3 isotopes of carbon, and they're just a nice way to build a working definition for what isotopes actually are. Isotopes are atoms with the same number of protons. All 3 of these have 6 protons, but with different numbers of neutrons. 6 here, 7 here, and 8 there. What that also means is that isotopes could be defined as atoms of the same element. They all have 6 protons, which means they're all carbon, but with different masses, 12, 13, and 14. These definitions for isotopes are some more key ideas. Make sure you pause and write those down too. So let's close the video by talking about what you might see on the periodic table for an element like carbon. So here's carbon's symbol from the periodic table. It's got the element symbol C in the middle. My atomic number of 6 is now shown on the top, and the atomic mass is now shown on the bottom, 12.011. So your periodic table symbol has pretty much the same information as these isotopic notations, with one glaring difference, and that is the atomic mass is now a decimal. That's kind of confusing because over here, those masses were whole numbers. What you've got to realize is that in nature, carbon exists as these 3 different isotopes. Some carbons have a mass of 12, some 13, some 14. So it's kind of like saying, which of those masses should we put on the periodic table. And what the periodic table does is it averages out all of the possible masses for these naturally occurring isotopes, and that's what gets reported. That decimal is simply trying to represent all of the different isotopes that carbon atoms can have, averaging them together to get 12.011. And with that, we conclude our video on subatomic particles and isotopes. Thanks for watching, and here's a brief summary.